Hi, once again, welcome everybody. Today we are having a session on starting a career in data science and machine learning. Jolomi Tosanwumi will be taking us today. Currently, Jolomi is a data scientist at Quick Check in Nigeria, where he has co-built machine learning models to score customers' loan application on Quick Check application and and on Jumia Pay. So Jolomi is also a data analytics and SQL instructor at UTVIA, where he teaches postgraduates for data analysis. He's a graduate of mechanical engineering from the University of Benin in Nigeria. He loves working with data, and he has a penchant for using machine learning to solve organizations' problems. So today, Jolomi will be taking us about starting a career in data science and machine learning. So if you're interested in machine learning, if you are enthusiastic about having a career in machine learning and data science, Jolomi is going to answer all of our questions today. Thank you all. So over to you, Jolomi. You can start your session.
All right, thank you, follower. Yeah, let me just confirm if we can hear me. So can anyone hear me? Let me just
Yes, I
confirm.
can hear you.
All right, great. Thank you very much. Yeah, thank you for this opportunity once again to everyone, members of this team and the AfriCode. Yeah. All right, so let's get in. So I'm gonna start sharing my screen right away. Prepare a few slides here. And you can also confirm if you can see my screen.
Yes, I can see your screen.
All right, thank you. So I'll be speaking on starting a career in data science. And all right, so about me, so Jeremy to sound with me, and I'm a data scientist at QuickCheck. Yeah, I love anything data, machine learning, deep learning. So work on a number of projects, an open source project, and writing some articles on blog or publish on Medium into data science. So some articles include implementing beta scoring carriers, and my skill stack include SQL, Python, R, SPSS, deep learning, machine learning, and natural language processing. So at QuickCheck, we use QuickCheck is a loan application in Nigeria, so where we give micro loans to customers. We are among the top 5 loan companies in Nigeria, and what makes us unique is our usage of machine learning in scoring customer loan applications. So we also have a partnership with Jumia Pay. So if you're on Jumia, let's say you want to order some products, and you don't have the money instantly, you can also take a loan through the Jumia Pay app. And of course, all applications are routed to QuickCheck. So our machine learning models have been trained to predict if a particular user who is applying for a loan is going to pay back, or if he or she has the ability to pay back or not. And they're based on the model's prediction, is going to decide if it's going to grant the user's loan or not. And the granting of loan and disposal of loan and all of the decision by the machine learning model, all of this take less than a minute, and it's very, very fast. So this is what makes us unique and a top competitor in the Nigeria fintech space. All right, so with an average loan application of 5,000 per day at QuickCheck, so our model grants about 2,000 per day, and with over 90% accuracy. All right, great. So all of these are the work of machine learning. And just a bit quote from Tim Nock. He said, hard work would be talent if talent refused to work hard. So yeah, so of course, machine learning, the tech space. Yeah, one thing that is common to everyone who is making it out here is that, yeah, they're hardworking. All right, so today we introduce us to AI. We talk about the applications of AI. We talk about data analytics, data science, some of the learning platform, and then I'm going to share some final thoughts with us. So let me introduce us to data science. First, let me just play a video for us that's just to, yeah. So this video was made by a machine learning model. So it was composed by a model that was built by NVIDIA. So it's kind of become the status quo national anthem of data science and machine learning. So let me just confirm if we can see. Okay. All right.
I am a visionary, expanding our understanding of the smallest particles. And the infinite possibilities of the universe. I am a guardian, protecting us on all of our journeys. And ensuring our most precious passengers make it home safely. I am a healer, searching for hidden threats in every cell. And delivering precise care with every breath. I am a helper, taking on complex tasks in the most challenging environments and giving our crops room to grow. I am a creator, transforming the very fabric of our everyday lives and using the creative DNA of the masters to inspire a new generation of art. I am a learner, taking just minutes to discover how to crawl, walk, and stand on my own. I am a storyteller, giving emotion to words. Und die Sprachbarrieren abzubauen. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
All right. All right, yeah. So that's just an intro video introducing AI. Yeah. So the music for that video itself was composed with a machine learning model that have been trained on music and the sounds and making documentaries and stuff like that. So yeah, so that's part of the interesting thing that AI has been used for. So back to our slide right away. Okay. All right. Let's see. Let me just confirm if we can see my slide. Hello?
Yes, we can. Yes, we
okay,
can.
all right, great. Okay, so we start by asking the question, so what is AI? So AI is short for artificial intelligence, and it is, generally speaking, it is the intelligence demonstrated by agents such as digital computers or computer control robots that makes them to perform tasks commonly associated with intelligent being. So, and this intelligence is often gotten by training these agents on data. So we're going to look at what data is in a bit. And so you may want to ask, why the hype? Of course, why the hype? But artificial intelligence, machine learning of recent. Yeah, so one of the reasons why we are interested in this stuff, number one is because, of course, according to Domo, about 2.5 trillion bytes of data are generated every day. And then in the 21st century, we now have robust storage capacity. So why not store and learn from this data like we do learn from our experience? Of course, we know that before now, centuries past, it's very difficult to store large amount of data. But then science and technology have so advanced that we can store large amount of data. So since you have the data, why not use it? Just like we human will learn from our experience. For example, if I know fire hurts because it burns, because I've had an experience with it before, I've learned from someone else's experience. So why not use this data in our business model or in our institution to drive decisions? All right. Another reason why AI is important is because it has application across all fields. So in fact, it has application across all fields, from the health sector to the fintech, business, government, sports, all makes use of data. So in fact, any institution that stores data and that values data can use that data to optimize their process. And then we have this saying, of course, part of the hype going around is that data is the oil of the 21st century. So it is a promising technology with almost limitless ability. So, and why the hype again? At the end of the day, it has proven to work. So top companies, 4,500 companies, most of them make use of AI, they make use of machine learning to optimize their process. And we all know some of the huge profit that they make and add a standard amongst their competitors. So AI works, machine learning works. And there it's also another thing that may interest you about AI is that it has been constantly been ranked in the top 5 skills to learn the past 5 years. So that consistency in being ranked among the top 5 skills, the top 5 on-demand skills, makes it very interesting for us to look at. And then you can learn it irrespective of your background. So whether you are from the arts, science, social sciences, law, anybody that can code or understand basic logic can learn AI if he or she wishes to do so. And yes, high demand equals IP. So one of the things that makes us interested in AI, of course, the money. And just like Wayne, I often advise people to skate to where the puck is going to be, not where it has been. So AI and artificial intelligence, data science, they are all becoming the status quo. They are all being integrated into different institutions, even some feeds. Most feeds that are not STEM related are now having courses on data science, data analytics, and as part of their major or minor. All right. Okay, so let's look at some of the fields where AI is being applied. So we can apply AI in the health sector, and it's one of the big applications or big discoveries that it has been made in that sector is that it can be used to detect cancerous cells or to diagnose rare disease and non-rare diseases. Imagine, because especially let's look at rare disease, for example, there are many symptoms that a patient can have, and then sometimes doctor trying to check each of these symptoms one after the other before coming to a consensus about the particular disease that is affecting that person. Sometimes kind of a tedious process. So with machine learning, we can train an agent on the different symptoms associated with different diseases, and in less than minutes, when you just feed in those symptoms, it can help in diagnosis. In finance, it's used for forecasting, analyzing trend, and their causes. So in finance, AI has big application there. So we talk about modeling, forecasting trend of the market, the forest market, the stock exchange market. AI can also be used there in transportation, self-driving cars. Also have application there is popular use case of AI in social media recommender system. Whether you're on Twitter, Facebook, you just see some feeds that come up on your page or some connection that have been recommended to you. All of these are the work of AI, and AI has application in every sector that has data. So long as sector can store data, AI can be applied there. Okay, so let's look at some practical applications. For example, at Quick Check, we use AI to score customer loans application. I think I've spoken to us about that. So we basically, when you apply, we choose some model that be trained to observe and customer loan application. So that model is able to predict if this person is going to pay or not. Then even in your smartphone, AI is close to you. Micro intelligence, like three fingers to lock your screen or to take a selfie. All of these are the work of AI. Tesla's self-driving cars, Google search engine is powered by AI. Right? We talk about Google Translate. You just put in something in a search query, and then you get your results. All of these are powered by AI. Microsoft also, they use AI to help and write and visualize charts. I think I've come across a new Microsoft Office product that uses text to speech. So, and this part of the future. So the future, I think we'll get to a time where we may not need keyboards on our system again. So you can just type in something by just speaking to your computer. All of these are the work of AI. Then NASA, I'm a big fan of NASA. I follow a lot of their projects. My favorite NASA project is Voyage. And then this Perseverance rover. So it's a robot that is currently in Mars, and it's being powered by AI. Yeah, autonomous robots that explore Mars. So this robot that we train to move and navigate through obstacles, to detect minerals and useful information in an environment like Mars. And I think it's two-in-one robot. We have a mini helicopter, which is called Ingenuity. Yeah, so you may read about their project. So Netflix, Facebook, Twitter, LinkedIn, Instagram, all of these, they all use AI to build recommender system. So we see some of the applications, practical applications of AI. So remember I said the power behind AI is data. So let's look at what is data. Simply put, data is just a collection of pieces of information, right? So it can be structured data or unstructured data. So when we say structured data, generally we're speaking about data that is organized in a tabular format. Then unstructured data, not necessarily organized in tabular format, so they can come as text, they can come as images, audio, videos, anything else. And if you're smart enough, you can generate data from anything. So if I look at you, for example, I can start generating data, your eye, the distance between your two eyes, your hair color, your eye color, your face, your weight, all of these are data that I can just generate by just looking at you. So if you're smart enough, you can generate data from anything, and then you can use that data. Most time, the aim of data science and machine learning is to see these data, these features of a particular object, how they are related with another property of that object. So we're going to look at those in a bit. All right, let's look at the branches of AI. We have data analytics, data science, and robotics. So this session will focus on data analytics and data science because they are strictly data-based, right? Okay, so what is data analytics? So data analytics generally refers to the branch of AI that uses data to answer business questions. And not only to stop at answering the question, but also to give data-driven recommendations. So for example, let's say you work in a firm like QuickCheck. So you may be asked to give answer to certain question. For example, what is the trend that is common among applicants in Lagos or from Ghana and stuff like that. So generally speaking, data analytics involve data description, diagnosis, and prescription. So in description, you are basically describing the data. So what are the trends? What are you seeing? What is the distribution like in the data? Basically describing the measures and metrics that we use in describing data, things like mean, median, measures of central tendency and dispersion, and all of this stuff. They are mainly used in data description. Then diagnosis, may be asked to diagnose, okay, why is sales going down the past month? So diagnosis involves you trying to look for the root cause. So it involves root cause analysis and stuff like that. Then prescription, all about giving recommendation, right? We do stuff like hypothesis testing, that's A/B testing, trying to, okay, based on your diagnosis, okay, what's the way forward, stuff like that. So a data analyst, so this is part of his job, right? He uses data to make description, diagnosis, and prescription. All right, so let's look at the tools that should be present in a data analyst toolkit, right? So number one is SQL. Yeah, although we have other variants like no SQL, but basically most time we use SQL. Or generally speaking, I advise everyone to be tool agnostic. tool agnostic. So don't be tied to a particular tool and say, oh, I'm Pythonista. If you're not Python, give me Python or I die. No, I will always advise people to have this flexibility to learn the tool that your organization is using. So yeah. So, but most time SQL. So SQL is basically a standard language for communicating with databases. And then for a data analyst, you need to have a tool that is optimized for only data exploration. So that's where tools like Excel, Google Sheet, SPSS data, SAS, and so on comes in. And then you need to have a tool that is optimized for data visualization, right? So data visualization, at the end of your data exploration, you want to tell the story, you want to communicate your findings and your insights. You use the popular tools in that area of visualization, communication of a site. They are Microsoft Power BI and Tableau, right? And then some math key are also needed. Yeah, true. So statistics and probability. Yeah, so it's basic mathematical skills that are needed in a data analyst toolkit. Okay. So where can you learn data analytics from? So it is about starting a career in data science. So we are looking at data analytics now. We come to data science in a bit. So where can you learn this key from? How can you go about starting a career? Of course, at Utiva. Utiva is it's a tech learning platform, online learning platform. So you have access to live section, to live training session like this. So yeah, they have some scholarship and it's also paid. We have Coursera, of course. I know we all know Coursera. Yeah, Coursera, a very nice platform for learning courses, and data analysis is also included there. We have Udacity, Data Camp, Udemy, LinkedIn Learning. So all these are some of the stuff. Of course, there are more than this. So these are just the one I'll be able to pick from. Yeah. So they are all nice platforms for learning. So some of them are free, some are paid, some give financial aid and scholarships, right? Okay, you can check all of this out. These are part of my recommendation. Of course, there are also others outside of here. And especially if you are a mentor, mentee in AfriCode, I believe you should be familiar with all of these or most of these, right? Okay, so let's look at data science. Now, we have looked at data analytics. So they do basically three things: data description, prescription, diagnosis, and prescription. So who is a data scientist? So a data scientist is someone that has the skills of a data analyst plus some other things, right? So let's look at the other things that the data scientist can do in addition to describing, diagnosing, and prescribing based on data, right? So a data scientist, of course, has the skill of a data analyst, right? And is also capable of using algorithms to make prediction. So in addition to description, diagnosis, and prescription, for a data scientist, we now have prediction, forecasting, and actions, right? So actions, for example, let's say a data scientist is capable of training a model on your smartphone to detect three fingers. So if the user display three of his or her fingers over the screen, so the phone is going to do some certain action, let's say taking a screenshot automatically and stuff like that, right? So all of these actions, all of these are part of the work of a data scientist, right? And speaking about algorithms, so the data scientist uses, the algorithms he uses can be broadly classified into two. We have the machine learning algorithms and deep learning algorithms. So we're going to look at each of these right away. So machine learning, short for ML, right? So machine learning generally, of course, like I said, there are a set of algorithms that data scientists uses to capture trend or patterns in a data to generalize. For example, I think the example I painted, let's say if I look at you, if I take features from you, data from you, like your height, your weight, your the distance between your two eyes, your eye color, stuff like that, your date of birth, your sex, all of this data. And let's say I want to see how all of those relate with your, let's say, lifespan or something like that. So just random lifespan, right? So in this case, lifespan is the feature I want to predict or model using the other set of data, right? So machine learning algorithms are just those algorithms generally that seeks to capture the relationship between some variables and another variable. So in this case, a machine learning model or a machine learning algorithm is an algorithm that we train to capture the relationship between all of these features: your height, your weight, your eye color, all of these, your arts, your blood group, and some of other information in your body, to see how it relates with your lifespan or how long you're going to live or something like that. Yeah, or if you're going to succeed in a particular course, let's say data science course, right? Where you may be saying, well, all of this may not have any relationship with it, but data most time can be very, right, shocking, right? You may be shocked to see some trend or patterns. Okay, I think recently there was an important insight that was gotten where some people use some deep learning model to look for insight. They were just looking for insights on the human eyes, right? And somehow the model was able to classify male eyeballs from female eyeballs, right? How the model was able to do that, I think with an accuracy of over 80%. So how the model was able to do that cannot be explained up to now, but the model learned something which has not been known in the field of biology. So researchers are currently trying to look at what the model have actually learned. So perhaps we could ever classify we could ever know if one is a male or female just by looking at their eyeballs, right? So there are some things there that were normally not visible to the human that the model will be able to capture. So machine learning, so this job of machine learning, a model that try to generalize and look for the relationship between certain variables with a particular variable, right? And we have, generally speaking, two types of machine learning. We have supervised and unsupervised machine learning. So for supervised machine learning, like the example I posed to us, you are generally trying to predict something, right? You're trying to look for the relationship between many things and something, or many things also, right? For example, this your weight, your height, and all of those, trying to look for the relationship with your success rate, right? In a particular course. So to the end that based on what the model have learned from data he has seen, is to be able to predict for data it has it seen, right? So yeah, stuff like that. So each time you're trying to predict a particular target variable, you are doing supervised machine learning. While unsupervised machine learning generally do not need a target variable, but it involves mainly looking for patterns, similarity, or clusters in data. So unsupervised machine learning, you don't have a target variable that you want to predict. You just have the data, all those features that I've given, maybe your height, your weight, all of these, you have those bunch of data without any target variable to predict. So what you can mostly do with that data, maybe you may want to look for clusters, right? Are there some similarity between certain weight and height in that data? Maybe people from this state, they tend to have, there's kind of a cluster of their weight and height, stuff like that. Yeah, so they are all part of unsupervised machine learning. So some popular machine learning algorithms evolve. They include linear models like, I don't want to bog you with the technicality here, but linear models that tend to model linear relationship. For example, linear regression, logistic regression. We have tree-based models and Bayesian models. So if you are familiar with probability, yeah, let's talk about the Bayesian theorem. Yeah, using that kind of theorem to model data. Now let's look at deep learning. So machine learning algorithms, sorry, where was I? think skip this. Yeah, so machine learning algorithms are generally not neural network based, but deep learning algorithms are neural network based. So deep learning are also set of algorithms, those set of algorithms that try to model the relationship between certain variables and another variable, but this time they use they try to mimic the working of the human brain, right? Like this figure you're seeing here, we have neurons, right, connected together, and it's called deep learning because you can go ahead and have many layers of neurons. So each of these dots here is a neuron. Then this vertical group of dots, or the vertical group of neuron, is called a layer. So this is the input layer, this is another layer, hidden layer, then the output layer. So a neural network can have as many layers as it was. And when we see, this kind of how our brain works, right? It consists of billions of neurons that are connected together. So let's say when I use an ice block to touch your skin, right? So that signal, that electric signal is being sent to your brain, and your brain has an input layer like this that is connected to another hidden layer, an hidden layer. That correct is transformed to a new form that will be sent to your body, to your hands and your muscles for you to now act and maybe scream, "Oh, that hurts," something like that. So this kind of how our brain works. Right, so deep learning models are those group of models that kind of mimic your brain, that are working of your brain by connecting neurons together. And of course, we don't have the organic neuron in the brain. So how do we do that? All of this at the end of the day, they are just linear transformations and non-linear transformations. Just some transformations going on here, right? Some mathematical transformations. So that's neural network, and they mimic the human brain. And popular neural deep learning models, they include multilayer perceptron, that is MLP. We have CNN, which is convolutional neural network. This one mimics the way the human eyes sees, and this is very powerful for computer vision, right? Yeah, computer vision and image detection. So we have RNN, which is recurrent neural network. We have LSTM, which is short for long short-term memory. Long short-term memory. This is very powerful for forecasting time series data. Then we have GANs, that is a generative adversary network, which is very powerful for building things. And we have a lot of models. So machine learning and deep learning is still currently under research. So more models are being introduced every day and every month. So researchers are working, it's pretty fresh feed, so you can dive in and get going in a matter of months or years. Yeah. Okay. So for a data scientist, what are those tools that should be present in his toolkit? So number one, of course, all the data analyst tools, which is SPSS, Excel, Tableau, Power BI, and stuff like that. In addition, Python, R, so Python and R and their corresponding libraries. So these are two popular tools that are used in building machine learning models. We have TensorFlow, Keras, PyTorch, OpenCV. All of these are deep learning libraries that have implementation in both Python and R. Yeah, they are very powerful for neural network. Then we have Git for version controlling, because you're going to be working with a team. You're going to have different versions of your model. So Git is a tool that is optimized for controlling different versions of what you're doing. So in this case, models, right? So cloud computing, for example, AWS, Azure, and Google Cloud, all of those very important, especially when you're working with big data, right? For example, there's some data that your Excel cannot carry, so you may need to move to the cloud for more compute power and for more virtual machines or stuff like that. Yeah. And then statistics, probability, calculus, matrix, and vector algebra. So all of these are be used as just a bit of mathematics here. So I think the data scientists will do some extra mathematics here. So at the end of the day, what is going on in neural network as kind of calculus, some calculus stuff are going on there. So all of this should be present in your toolkits if you want to venture into data science. Okay. Where can you learn data science from? So I would recommend World Quant University as my first choice here. So World Quant University is an online university. It is free. It is free for learning machine learning. 6 months, yeah, using Python. Yeah, and you're going to be admitted, but the admission is competitive. Just answer some basic Python question and mathematics question. So yeah, it's where I learned my machine learning from. So that's why I'm recommending it. And they are very nice. Yeah, we have Udacity, yeah, for data science, machine learning. We have Coursera, Data Camp, Khan Academy, Udemy, with Python, Codecademy, Pluralsight, SoloLearn. So all of these are powerful. I think from here downwards, they are mainly used for learning Python or R, right? SoloLearn, you can learn Python, R. Pluralsight can learn Python, R. Codecademy can learn Python, R. With Python, you can learn Python. I think from here upward, you can learn the application of Python or R for machine learning, right? Yeah. Okay. right? And I think AfriCode offers a scholarship. So if you're not part of AfriCode, you may want to join the next session, and you may be lucky to get funding to take a course in any of these platforms. Wonderful platform and wonderful things to learn from them. Okay, so let's look at some of the projects. So one of the beauty of data science is that you can easily practice, right? Even though you don't have internship, you don't have a job, you can practice, you can build a portfolio, you can build a CV, a good CV, you can have hands-on experience while sitting from your house. And popular number one platform in getting hands-on experience is Kaggle. So Kaggle is a website mainly built for data scientists. So you have access to thousands of data sets. So you can work with real life data set on Kaggle, and Kaggle also has data science competitions, right? So we have competitions ongoing on Kaggle every day. So competitions that are worth $10,000, $20,000, as the case may be. So most of the competitions just involve you working with the data you are being given to build the best model. There maybe the model with the best accuracy, the person's model with the best accuracy would win the competition. So we have lots of competition going on simultaneously on Kaggle. If you're going to be a data scientist, I think it's compulsory from my point of view to have a Kaggle account, right? So Amoye is a tech head in Nigeria and also in the US, where you have hands-on experience. So they give you experience to work on open source projects where you work in a team. It's free. You can get hands-on experience. I participated in it in 2020 for 6 months, and it was nice. So part of what I used to build my portfolio, my CV, I had experience leading teams on different projects, credit card fraud detection project, and all of those. Right, nice stuff going on there. The World Quant University also have a applied data science lab for having hands-on experience. Forage is a website for data analysts, so where you have virtual internship with companies like KPMG, PwC. So you just work with their data maybe for 1 month, and then you just get a certificate, right? Stuff like that. And we have UCI Machine Learning Repository where you can get data and work on. We have data.gov. Akarank is a popular website for taking coding challenges. So you could also take, maybe you've learned Python on or R or SQL and you want to maybe improve yourself to the extent of answering some questions within some few seconds. Akarank and Solo Learning are very good for stuff like that, for challenges, right? Okay. Yeah. So final thoughts. AI is constantly advancing. And new methodologies are being discovered every day. So you can get into it no matter your background. AI is waiting for you. If you're interested, you can join the train, and let's see what become of that. So most AI algorithms, they are very efficient, right, than manual tasks. And of course, they have a downside of people losing their job. Of course, we have people, imagine, let's say for us, quick check. Yeah, although it is efficient for scoring customer loan application on the Go, but I think before now, maybe in the 19th century or 20th century, when people apply for loan, they queue up, and we have people that go through their application manually and stuff like that. Yeah, all of those people won't be able to work in the 21st century, because now all of this will be automated through AI. But the good side of people losing their job, those manual jobs, is that we have more job for data scientists, right? So that's why it's on high demand. And at the end of the day, it scales easily, right? Imagine application, 5,000 applications per day. You want to work with all of this efficiently. AI, I think, is the best go, right? So most AI algorithms, to be sincere, they aren't new. They've been developed a long time ago, but what just happened is that we just started having enough storage and compute power to process this data. So that's why it's as though the trend is just came in the 21st century. Yeah, so most of these algorithms, they've been developed, but since we got the compute power and storage power, why not utilize them, right? And improve our businesses. Yeah, so that is it. Thank you. Questions? Yeah. Hello?
Well, thank you so much, Jolomi. You've shared a lot of knowledge. Thank you for your presentation. I don't know if anyone among the audience has a question for Jolomi. Anyone? Well, pending when anyone talks, I think I have a question in mind, Jeremy. So I've tried learning machine learning, I've tried deep learning, and usually, can you hear me?
Yes, I can.
Oh, okay. So usually I figured to some extent some mathematical knowledge or statistical knowledge are required. And so how much of mathematical knowledge do I actually need to begin a career in machine learning and data science in general? How much mathematics do I need to understand?
Yeah, so I think like in the slide I shared, generally statistics, yeah, I mean statistics, yeah, you should know statistics, you should be comfortable with statistics, right? The general basic principles of statistics, right? The intuition of all of those measures of central tendencies and dispersion, not just knowing that formula, but the intuition, what they actually represent, right? And stuff like that. Then probability, in fact, machine learning algorithms, most times, especially classifiers. I didn't speak about regressors and classifiers, but classifier, let's say you build a model that, for example, in our case, that predictive a customer loan application, if it's going to grant a loan to that person or not. So all of these are based on probability. What the model is just basically doing is associating probability values, right, to that person's application. So what is the probability that this person is going to pay back? That's what the model is trying to calculate, right? So you need to understand how the model does all of these things, because you are the one building the model. So you are the one creating it. So you have to have understanding of probability, basic probability, right? Bayesian and frequencies probability, and the different probability distributions we have. Then calculus, you just maybe if you're comfortable doing this basic differentiation integration, right? And partial differentiation. Yeah, I think you should be okay with that. Then matrix transformations, you can learn basic matrix transformations. Yeah. So you don't need to know all of mathematics as a whole, just statistics, probability, matrix, and vectors. You should be good to go with data science. You don't need to bother yourself about other parts. Yeah, I think. Yeah.
All right, thank you. Thank you for answering my question.
Yeah.
Thank you so much. So Samuel in the participants, he has a question. Samuel, you can and ask the question.
First of all, thank you very much, Mr. Ajilomi. Can you hear me, please?
Yes, I can.
Okay. During the course of this meeting, in the slide there, you mentioned two of the programming languages available we can use for data science.
Yeah.
You mentioned Python and R programming language. So I just want to know, between the Python and R, which one would be good for someone who is just starting, and why would you suggest that one?
Yeah, so for someone who is just starting, there's no general answer to that, but first question I want to ask that person is, okay, do you have any prior knowledge of any other programming language? That'd be one, because if someone that want to learn either Python or R that has already known Java before, let's say C++, so of course, that person is comfortable with the idea of object-oriented programming. So I want to say that person should go with Python, right? So that is one. But generally speaking, I would say if you have a company in mind that you want to work with, the language that that company is using, I will advise you to learn that one. But if you don't have any company you want to work with, you just want to start with one. Generally, people recommend Python because of it's a multi-purpose programming language. So why would recommend I will recommend Python for you to start with Python. I mean, start with Python. It doesn't mean you won't learn R at the end of the day. It's because it is mostly used, and number two, it is multi-purpose. So apart from using Python for machine learning models, you can also use Python for development, for software development and web development. So at least you've learned, we have some idea of the workings of all of this stuff, right? Just by learning the basics of Python. So by virtue you want to break into software or web development, it becomes very easy for you. But I think I will just strictly on data science, but Python is for data science, web development. You can use stuff like, you can use Python library like Django for web applications and all of that. Yeah. So I would recommend Python just simply because of its multi-purposeness. Yeah.
All right. Thank you very much. Thank you very much.
Yeah, you're welcome.
All right, thank you. Thank you, Jeremy, for answering our questions. I don't know if anybody else has other questions. Please feel free to ask.
Yeah. Hello? Can you hear me?
It's not talking.
Yeah.
Okay, my name is Samuel.
Okay.
Okay, my name is Samuel from FUT. Okay. I've been into data science for a while now. And you mentioned the jobs growing up, good thing for data scientists. But I've not been able to get something to do. So I've been wondering maybe something is wrong with my CV or something like that. So I want to know if you guys have a meeting coming up, like how a data science can prepare his CV or something like that, his resume.
Okay, so speaking about meeting coming up, I think we've had a meeting, not for data science, just preparing a CV or resume generally, but I don't know if I could ask an upcoming event that I think
previously organized a meeting for data science for resume building. If I want to check out that meeting, I will drop it in the chat here. But Julomi, do you have an advice for him?
Sure. Yeah, sure. Like I think if you look at the last slide that I shared, data science, one of the beauty of it is you can practice, right? You can practice. So what most of the interviews I've attended, they will always ask me to walk them through my GitHub repository. So I think you should be comfortable with using Git and all your projects. You should do projects, personal project and group project, platform like Amoye. You can get experience on Cargo, also you can work with data, just do an analysis on the data or try to predict something or try to solve one of the problems on Cargo and upload it to your GitHub, right? And then put a link to your GitHub repository on your CV, right? And then you could also look at Amoye also to work and get some hands-on experience. Forage is also there to get hands-on experience. So the beauty of data science is that all of these experiences can actually get you a job, right? Even though you haven't worked in an industry before, learning from all of this can actually build a portfolio for you. Yeah, that was what I used to build back in 2020. So, and I got a job immediately the next month. So just make sure you've worked on interesting projects. You are able to defend the project. You know what you're doing, and personal project. And I think your project will be probably classified into personal project and collaborative projects, so that they will be able to assess how you can work with a team and how you can work personally, right? So you can work on some personal projects and stuff like that. I also advise having a good LinkedIn profile. If you've learned something new on machine learning or data science, you can write an article about it, a blog about it, put yourself out there. Yeah, all of those things are very, very important, right? Yeah. So yeah, for myself, when I was working on personal project on Cargo, worked on projects like classifying handwritten digit between 0 and 9. So be able to predict if this digit is 0 or 1, that is handwritten. Stuff like predicting human deforestation in Amazon. So train the model that can look at an image of Amazon and predict that, oh, a human activity just occurred here, and these guys, there was deforestation here. So on Cargo also, there were data sets for credit card fraud detection. Many interesting projects, even for FIFA to predict the scores of matches, Bitcoin. All of these data are available on Cargo. US election data sets. There are data sets that you can work on, right? Thousands of data sets. You can work on all of these and add them to your CV. Yeah.
Wow, amazing, Jeremy. Thank you. Thank you so much for that explanation. So the main takeaway is to actually have projects in your CV and have something you can use to convince recruiters. Does anyone have any other questions before we round up?
Please, sorry, I asked for the slide for the presentation. I don't know if
Yes, I've sent it to your emails. I've sent them to the emails dropped on the Yes.
Okay, thank you very much for that.
Okay. So if there are no other questions, I think we can call it a day and round up the session. Thank you so much once again, Jolomi, for sharing your knowledge. Thank you so much for sharing your insights. Can you drop your LinkedIn URL in the chat in case anyone wants to reach out to you or ask you further questions?
Okay, sure.
All right, thank you.
Sure, yeah. So I just made the slide to be open to the general public. So when you click on that link, you have access to this.
Awesome. I'll append it to the YouTube video.
Slide, right?
Thank you also everybody for joining this session today. We appreciate your time. We are grateful you actually took time to stay with us and learn everything we have to offer today. Thank you. We'll see you next session.
My LinkedIn link is there. I just sent it.
So Jolomi just sent his LinkedIn. In case you have further questions, feel free to reach out to him. Feel free to ask him more questions. I'm sure we'll be happy to take all your questions and to help you. Bye, everyone. I'll end the session now. Do have a restful weekend.
All right. Thank you. Yeah. Bye.